Yo guys, welcome to this new episode of Talking About Science. In this podcast we talk about all science. Listen, relax and most important, learn. Okay, today we will talk about the weather. We will talk about thunder, tornadoes and tsunamis. Okay, first we will talk about thunderstorms. I'm 100% sure that you know it. A big lightning strike in the sky. But how is it created? How does a thunderstorm arise? Thunderstorms are caused by friction between strongly rising warm air and strongly descending cold air. This is also the reason that it often thunders when it has been hot. Okay, but there are three kinds of thunderstorms. I will explain them all. On Earth we have single-cell thunderstorms, multi-cell thunderstorms and supercell thunderstorms. We will begin at single-cell thunderstorms. Thunderstorms created by just one convection cell in the atmosphere are called single-cell storms. Most of these are small, lasting only about an hour, and are also called ordinary thunderstorms. These storms often form during summer and include towering cumulonimbus clouds that can grow 12 kilometers high in the atmosphere. Rain and lightning are common. Sometimes hail falls, not every time. Multi-cell thunderstorms. Some thunderstorms are made from many convection cells, moving as a single unit. These are called multi-cell thunderstorms. Often the convection cells are arranged as a cluster, with each cell at a different stage of the thunderstorm cycle. Multi-cell storms are along a cold or warm front where warm air is pushed high into the atmosphere above cold air, often form a line called a squall line. The squall line can be up to 600 miles, 1,000 kilometers long. Strong wind gusts often blow just ahead of the storm. Okay, the last one, supercell thunderstorms. Thunderstorms with deep rotating updraft winds, called supercells, are very, very large and last for hours, releasing huge amount of rain and sometimes even baseball-sized hail. They include fast-moving convection, air zooming upwards at as much as 175 miles, 218 kilometers per hour. Rotation in supercells sometimes forms violent tornadoes, the largest and most damaging type. Because the storms are so long-lived, several tornadoes can be produced from one supercell thunderstorm, and clouds grow up to 18 kilometers in the atmosphere. Supercells are the least common type of thunderstorm. Okay, now let's talk about one beauty from nature: tornadoes. Tornadoes are created when warm and cold air are mixed with each other. That's exactly the reason why the state Colorado in the USA has the most tornadoes. The cold winds from Alaska and the warm winds from the Caribbean are mixed together and create a tornado. Every tornado can have a destructive power, mostly combined with a supercell thunderstorm. Okay. Tsunamis. You might heard about it. What is it and how is it created? A tsunami. A tsunami is actually a massive earthquake in the sea. Well, a massive earthquake in the sea created a tsunami. The higher the Richter scale, the bigger the earthquake. In 2011, Japan had a massive earthquake in the sea. Japan is an island, so the tsunami was coming. When everybody thought it was over, the tsunami was still coming, and it had a massive power. The tsunami destroyed a whole city called Fukushima, and in Fukushima was a nuclear reactor. When the water arrives on the land, he hit the nuclear reactor. But in that nuclear reactor, as in every nuclear reactor, were uranium. That's what they use for creating energy there. More explanation about a nuclear reactor later in a later podcast. The accident was triggered by the Tohoku earthquake and tsunami on Friday 11 March 2011. On detecting the earthquake, the active reactors automatically shut down. The normal power generating fission reactions. Because of these shutdowns and other electrical grid supply problems, the reactor's electricity supply failed, and the emergency diesel generators automatically started. Critically, these were required to provide electrical power to the pumps that circulated coolant through the reactor cores. This continued circulating was vital to remove residual decay heat, which continues to be produced after fission has caused. However, the earthquake has also generated tsunami, 14 meters, 46 feet high, that arrived shortly afterwards and swept over the planned seawall and then flooded the lower parts of reactor 1 to 4. This flooding caused the failure of the emergency generators and loss of power to the circulating pumps. The resultant loss of reactor core cooling led to 3 nuclear meltdowns, 3 hydrogen explosions, and the release of radioactive contaminations in Unit 1, 2 and 3 between 12 and 15 March. The spent fuel pool of previously shut down reactor 4 increased in temperature on 15 March due to decay heat from newly added spent fuel rods, but did not boil down sufficiently to expose the fuel. Okay. Of course, this was a massive rampage. That's the power of nature. It's beautiful. Nature is beautiful, but sometimes also horrible. Okay, guys, I hope you learned something new today, and I see you next time. Later.